Question 5 says a body of mass 5 kg. So they give us mass. A body of mass 5 kg is suspended from a spring and causes an extension of 10 cm. They give us extension to be 10 cm. So we have extension to be 10 cm. This is for mass. And this is for what? Extension. They say calculate the spring constant. K is unknown. This is the spring what? The spring constant. They also gave us from the question that we should take acceleration to gravity G to be 10 meters per second squared. Now from the question, if we recall Hooke's law states that the force is equal to what? Kx, where K is the spring constant and X is the what? Extension or elongation. Now we have the value for what? We don't have the value for K, but we have the value for X and we have mass. Recall that F is equal to what? mg. Force is equal to mass times what? Gravity. They give us, don't forget, they give us mass and they give us what? Acceleration due to gravity. If we substitute this equation, we have F is equal to mg. Our m is what? 5 kg times our g here is what? 10. 5 times 10 gives us what? 50 newtons. Now we have gotten the value of F to be 50 newtons. Let's substitute it into this equation. If we put this into this equation, we have F is equal to Kx. This gives us F is what? 50 newtons is equal to, our K is what? Unknown. And our X, the extension, is what? 10 cm. Now, this is in cm. We need to convert this from centimeters to what? Meters. If you convert from centimeters to meters, you divide by 100. Converting this from cm to meters, you will divide by 100. Cm to meters, you divide by 100. So we have 10 cm divided by 100. This take away this, we have 1 divided by 10 will give us what? 0.1 meters. Therefore, we have converted this extension from 10 cm to what? 0.1 meters. We are going to substitute this value now into this place for the x. So for x, we have times 0.1 meters. If we make k the subject of formula, we have k is equal to what? 50 divided by 0.1. 50 newtons divided by 0.1 meters. When we do the division, we're going to have 50 divided by 0.1 will give us 500 Newton per meters. Therefore, the spring constant in this question is given as what? 500 Newton per meter. This is the final answer. Question 8 says an object is dropped from 100 meters tower. What is its velocity just before hitting the ground? Take acceleration to gravity to be 10 meters per second squared. Option A says 40 meters per second. Option B, 44 meters per second. Option C, 45 meters per second. And option D, 50 meters per second. From the question, an object is dropped from a height. We have height to be what? 100 meters. It says, what is its velocity before hitting the ground? That is the final velocity. V is equal to what? Unknown. We don't know it. From the question, they gave us acceleration due to gravity to be 10 meters per second squared. Now, u, which is the final velocity, is equal to what? 0. It was not given to us in the question. Recall the equation of motion that v square is equal to u square plus 2gh. This will give us, this is 0 squared. V square is equal to 0 squared plus 2 times 10 times 100. This is equal to what? V square is equal to 2 times 10 is 200. 200 times 100 will give us what? 20,000. So you have 20,000. We are looking for V and not V square, so we take the square root of both sides. If we take the square root of both sides, we have V is equal to square root of 2,000, 20,000. This will give us what? 44.7 meters per second. If we convert, if we approximate this, we're going to have what? 45 meters per second. This is the final answer. So the correct option there is option C with 45 meters per second. Question 9 says 2 capacitors, 4 microfarad and 6 microfarad, are connected in series. What is their effective capacitance? 2 capacitors, 4 microfarad and 6 microfarad, are connected in series. What is their equivalent capacitance? We have the options there, A, B, C, and D. The term capacitance simply means the ability to store electric charge. For series connection, we have 1 over the equivalent capacitance is equal to 1 over C1 plus 1 over C2 plus 1 over C3 plus 1 over Cn. So any number at all, any number of capacitance. From the question, they gave us C1, which is the first capacitance, to be what? C1 is given to us in the question to be 4 microfarad. They gave us C2. C2 is given to us as what? 6 microfarad. Now, if you substitute this into this equation, we're going to have 1 over C equivalent to be 1 over C1. Our C1 is what? 4 plus 1 over our C2 is what? 6. This is equal to, when we have two fractions like this, we take the LCM. The LCM of 4 and 6 is what? 12. 12 divided by 4, you have 3. 3 times 1, you have 3. Plus 12 divided by 6, you have 2. 2 times 1, you have 2. This is giving us what? 3 plus 2 will give us 5 all over what? 12. We have the equivalent capacitance to be what? 5 over 12. Now at this point, we are looking for the equivalent capacitance and not 1 over this. We are just looking for this. So for us to remove this numerator, we take the inverse of both sides. This becomes C equivalent over 1 is equal to 12 over 5. Anything divided by 1 is that same thing. So we have C equivalent is equal to 12 divided by 5. We have 2.4 microfarad. So this is our final answer. The correct option there is option B, 2.4 microfarad. Question 10 says, a uniform rod of length 2 meters and mass 3 kg is pivoted at one end. What is its moment of inertia about the pivot? What is its moment of inertia about the pivot? A, 1 kg meter square. B 2 kg meter square, C 3 kg meter square, and D 4 kg meter square. Don't forget, from the question they gave us what? Length. Length is equal to 2 meters, and they gave us mass. The mass is equal to what? Mass is equal to 3 kg. Now, having done this, he said it is pivoted at one end. Moment of inertia simply means resistance to rotational motion, and mathematically it is represented as I is equal to 1/3 ml squared. We have the mass, we have the length. We are asked to find the moment of inertia. So I is equal to 1/3 into, our m here is what? 3 kg. Our length is 2 all to power 2. This will give us 1/3 into 3. This is 4. This will cancel out. We have what? 1 times 4. 1 times 4 will give us what? 4. Therefore, the moment of inertia is We have come to the end of today's class. Please don't forget to hit the like button, subscribe to this channel, and tell us other topics or subjects you'd like us to treat. Till then, see you in our next video.